Welcome to the session. Continuation of chapter 2, that is sinusoidal steady state analysis. With respect to chapter 2, I'm starting lecture 6. In the previous session that I discussed about what are the observations from a sinusoidal AC source across series RL circuit. A continuation of that, how to see the next circuit is a sinusoidal AC source across series RC circuit. A sinusoidal AC source across series RC circuit. Series RC circuit. Students, you have to draw a series RC circuit. It's a resistance. And this is the capacitance. Across this series circuit, we are connecting a sinusoidal AC source. Is V equal to Vm sin omega t. Then capital V equal to is Vm by root 2. That is RMS value of supply. RMS value of supply. Let the voltage across the resistor is VR and voltage across the capacitor is VC. Let this voltage is VR source. And this voltage is VC. Where VR, VC are the RMS values. These are the RMS values. VR, VC are the RMS values. Then you have to write the total supply voltage V equal to VR plus VC. VR plus VC. Then we know that what is VR equal to? This IR at angle of 0. What is VC equal to? I into minus JXC, capacitive reactance, capacitive impedance that you know. That is I into XC at angle of minus 90 degrees. I into XC at angle of 90 degrees. That is minus 90 degrees. Then what is V equal to? This VR is IR. This VC equal to minus J I into X. Take I is common. R minus Jx. Therefore, V bar equal to I into Z. What is Z here? Where Z equal to R minus Jx. That is for RC circuit, impedance Z equal to R minus Jx. For series RC circuit, the impedance is R minus Jx. What is Xc? 1 by omega C. It's also equal to 1 by 2 pi Fc. This is capacitive reactance. Capacitive reactance. Here you have to draw the phasor diagram. To draw the phasor diagram from this, what is the observation here? VR and I is in phase. For resistance, voltage and current is in phase. What about voltage and current for capacitor? This is minus 90 degrees now. Voltage lags the current by angle of 90 degrees. That is VR in phase with I because of 0 degrees. VR is in phase with I. What about VC, students? VC lags. It's minus 90 degrees now. VC lags I by angle of 90 degrees. Now, you have to draw the phasor diagram. Here I am drawing the phasor diagram. Then if you draw the phasor diagram, that I is the reference because in a series connection current is constant. This I is the reference. VC lags I. VC lags I by angle of 90 degrees. If you measure in clockwise direction, angle is negative. That's why it is a minus 9. VC lags I. Clockwise lagging, anti-clockwise leading. Clockwise angle minus. That is minus 9. VC lags I. But what about VR? In phase with I. In phase with I. This VR plus VC is nothing but a V. This is VR plus VC is nothing but this is tan. Clear, friends? Now, according to this is V. Then, according to parallelogram law, how to write V equal to square root VR square plus VC square plus 2 VR VC cos theta. But what is the angle between VR and VC? What is the angle between VR and VC? It's a 90 degrees. According to parallelogram law, how we can write VR square plus VC square plus 2 VR VC cos theta. Na? But theta is, that is angle between cos theta in the sense cos of angle between VR and VC. What is the angle between VR and VC? 90 degrees. Cos 90 becomes 0. That's why you can write V equal to square root VR square plus VC square. Then you write any formula here. What is cos theta? That is a power factor. From this, how to define cos theta, friends? How to define cos theta? That is VR by V. What is VR? I into R. What is V? I into Z. V equal to this one. I into Z. Then what you can get? R by Z. This is power factor. Cos theta equal to power factor. You can define what is tan theta from this. Tan theta equal to VC by VR. VC by VR. Like this, any formula you have. What is the sin theta from this? Sin theta equal to how much? This is VC by V. VC by V. These are the different formulas you have. But this is very. This is from the phasor diagram. Now you have to write, you have to draw the what impedance triangle. Can you try this impedance triangle? Clear, students? This is how I am drawing this phasor diagram. Current is reference because in series connection current is constant. We are in phase with current. VC is lagging because minus 90 degrees. No? It is a lagging. Then this is clockwise angle. If you measure in anti-clockwise, current is leading. Now draw the what impedance triangle of RC circuit. How to draw the impedance triangle of RC circuit. Students, impedance triangle of RC circuit. Right. What the impedance triangle of RC circuit. Then this is resistive and this is capacitive reactance. How to take this capacitive reactance? This is XC and this is Z. And this angle is theta. Then what the impedance Z equal to square root R square plus XC square, where XC equal to 1 by omega. What are the cos theta, students? That is the power factor. This is equal to R by Z. What is tan theta? This is important formula. In RC circuit, XC by R. In RL circuit, XL by R. Then theta equal tan inverse XC by R. Then what is sin theta I have to write? Sin theta equal to XC by Z. Sin theta equal to XC by Z. Then this is impedance triangle. This is XC by R. We can also write tan inverse. What is XC? 1 by omega. 1 by omega c. Once you know the impedance triangle, then how to draw the power triangle? Power triangle. Just every vector in impedance triangle multiply with I square. Then you can get the power triangle. If this is resistance, multiply with I square. That is I square R. This is equal to P, active power. This is XC, multiply with I square into XC, that is the QC. And this is which one, students? I square into Z. This is equal to apparent power or complex power. And this angle is theta. Then here also you have to define different parameters here. This is active power, this is reactive power, and this is the apparent power. Then what is the cos theta, students? P by S. What is sin theta? Cos theta is P by S. What is the sin theta? QC by S. What is the tan theta? Tan theta equal to QC by P. QC by tan theta equal to QC by P. Clear? We can also write S equal to R minus JXC. R minus JXC. This is Z equal. Z equal to R minus JXC. Multiply both sides with I square. I square Z equal to I square into R minus J into I square into X. What is I square into Z? Yes. I square R is P. I square XC is QC. This is the complex power. For RC circuit, this is the complex power. In RL circuit, we got P plus JQL, but here we are getting P minus JQC. Okay, this is about phasor diagram, impedance triangle, power triangle of RC circuit. And RL is completed, RC is completed. And one more important is a sinusoidal AC source across series RLC circuit. A sinusoidal, or to write a sinusoidal AC source across series RLC circuit. A series RLC circuit. Now draw the series RLC circuit, friends. This is resistance. Okay, and this is inductance, and this is the capacitance. This R, L, C. Let the voltage source is connected across RLC circuit. The sinusoidal voltage. How to write V equal to Vm sin omega t. Let the voltage across the resistor is VR. This is VL and this is VC. Then how to write this V equal to, you write VR plus VL plus VC, where VR, VL, VC is which values? RMS values. V equal to Vm by root 2, that is RMS value of supply. RMS values. Here this concept I have to discuss in two cases. Before this, we know this, what is VR equal to? IR at angle of 0. What is VL equal to? J into I into XL, that is I into XL at angle of 90 degrees. What is VC, students? Minus J into I into XC. This is how to write I into XC at angle of minus 90. From this, what are the observations, friends? We are in phase with I. What is VL? Plus 19. VL leads I by angle of 90. What about VC? VC lags I by angle of 90. Minus 90 degrees, no, it's a lag by angle of 90. Then you substitute the V equal to VR plus VL plus VC. What you can get, friends? V equal to VR plus VR equal to I into R. Is VC equal VL equal to J into I into XL. Then VC equal to minus J into I into X. So to write minus J into I into X. Then from this, what is V equal to, friends? Take I is common. R plus J into XL minus XC. J into XL minus XC. Then this V bar equal to I into, this is R plus J into XL minus XC. Now this is the impedance of the series RLC circuit. This is I into Z. Then Z equal to R plus J into XL minus XC. This is impedance of series RLC circuit. But here XL may be greater than XC or XC greater than XL. That's why I have to draw the phasor diagrams in two cases. That you have to concentrate. How to draw the phasor diagrams. This I am dividing into two cases. That is case 1. If XL greater than XC, greater than XC. Yes. In a series circuit, current is the constant. How to reference is I. Like I is the reference. Students, we know that the resistive drop is in phase with current. That is VR. What about VL? How take this is VR in phase with I. VL leads I by angle of 90 degrees. VL leads now. This is VL. Leads I. In which direction we are measuring the angle? That is the counterclockwise direction. In counterclockwise direction, that is anti-clockwise direction, the angle is measured as a positive. That indicates leading. In clockwise direction, the angle is measured as a negative. That indicates lagging. This is, I'm taking this one is VC. Here I'm taking if VL greater than VC. VL greater than VC. Now this resultant, this VL greater than VC. How take this is VL. This is the, then these two vectors are opposite direction. VL and VC vectors are opposite direction. This is VL means. Then what this amplitude indicates? VL minus VC. Then resultant is this direction. Let this angle is theta. Let this is the V. Then according to parallelogram law, how you can write, students? This V equal to square root. This VR square plus VL minus VC whole square. This is 5-star gunshot formula. Already questions are there based on this formula. Already different computations. But this formula written with assumption of VL greater than VC. VC greater than VL, how we can get later the rest. This is for VL greater than VC. Then V equal to square root VR square plus VL minus VC whole square. Then from this, how to define cos theta, students? Cos theta, that is the power factor. I'm writing power factor formula in terms of voltages. Then how to write VR by V. Then what is sin theta? How to write? From this triangle. What is the sin theta? This also 90 degrees. This is 90 degrees. This is 90 degrees. This is 180 degrees now. Always resultant is high voltage side. This is VL. This is VC. VC vector is this one. Don't confuse. VC vector I drawn small. This vector I taken a large vector. Why? This is VL greater than VC. Then resultant is in the direction of high voltage. Which is high voltage? VL greater than VC. That's why this is the resultant. VL minus VC. Then you write V equal to square root VR square plus VL minus VC. What is the angle between VR and VL minus VC? Can you tell? What is the angle between VR and VL minus VC? This is 90 degrees. No? This is VR. This is VL minus VC. What is this angle, students? It's a 90 degrees. What is the angle between VL and VC? If you take this one, this is VL and this is VC. What is the angle between VL and VC? That is 180 degrees. Is equal to 180 degrees. Then what is the sin theta from this? That is VL minus VC by V. This is V. Can you write what is the tan theta formula? That is VL minus VC by VR. VL minus VC. Like this, you have to write the different formulas. What is the angle between VR and VL, students? What is the angle between VR and VL? The angle between VR and VL. The angle between VR and VL is also 90 degrees. This is VL, no? This is VR, is also 90 degrees. Angle between VR and VL minus VC also 90 degrees. What is the angle between VR and VC? Can you tell? What is the angle between VR and VC? The angle between VR and VC also 90 degrees. This is VR, no? This is VC. What is this angle? 90 degrees. But angle between VL and VC or VL minus VC and VC, the angle between VL and VC is 180 degrees. Okay, this is the phasor diagram. Can you draw the impedance triangle? For case 1, I am drawing impedance triangle. Impedance triangle. Then if you draw the impedance triangle, let assume that XL greater than XC. By assuming XL greater than XC, I am drawing this one. XL greater than. Here VL greater than VC. Now VL greater than VC means I into XL greater than I into XC. That is the meaning. XL greater than XC. Then same we can get like this. This is the current in series connection. Current is constant. I remains constant. I is the constant. This is resistance in phase with the current. This vector is which one you have to take? This is XL. This is I. This is R, students. This is XL. This is XC. This resultant is XL minus XT. This is opposite, no? XL minus XC. This resultant is Z. This is theta. In terms of reactance, this impedance. Now, what is the impedance Z equal to? Square root R square plus this also. This impedance equal to R square plus XL minus XC whole square. This is because XL greater than XC. This is the impedance of series RLC, magnitude of impedance. Then from this, what is the cos theta? Cos theta equal to R by Z. This is same for R by Z. What is sin theta? XL minus XC by Z. What is the tan theta? This is very important. 5-star conditional formula. Tan theta equal to XL minus XC by R. That is for series RLC circuit. If XL greater than XC, how to calculate the angle? Tan inverse XL minus XC by R. Tan inverse XL minus XC. Then what is XL equal to? Omega. What is XC equal to, friends? 1 by omega. XL equal to omega L, XC equal to 1 by omega. Very important to concentrate. This is impedance triangle. Then how to draw the power triangles? I will explain. To get the power triangle, just each vector in impedance triangle multiply with I square. Multiply. It's very easy. Once you understood how I drawn for RL series circuit, then remaining is same. Just see which is lagging, which is leading. That's very easy to transpose. Then here I'm drawing power triangle. I'm drawing power triangle. If you draw the power triangle, as it is, you draw the impedance triangle. This is I. This is resistance. Resistance. And this is I into, this is I square into Z. This is I square into XL minus XC. This is XL. This is XC. And this is theta. Because XL greater than XC. So this is I square into XL minus XC. This you can write like this now. I square into XL minus I square into XC. What is I square into XL? QL. What is I square into XC? QC. That formula is already. This is I square into R. What is I square into RP? What is I square into Z? S. This is which triangle? This is the power triangle. Now you write any formula. If you want to write this I square into XC, no? This is QC. How to write this is I square into XL, no? QL. Then this is QL minus QC. Resultant is in XL greater than XC, no? Here XL greater than XC. That is QL greater than QC. QL greater than QC. Now according to parallelogram law, how you can write? S equal to square root P square plus QL minus QC whole square. For this case also you have to write here in RC circuit also. What is S equal to square root P square plus Q square. P square plus Q. Here also same, S equal to square root P square plus QL minus QC whole square. Then you write any formula. What is the cos theta? Cos theta equal to P by S. What is sin theta, friends? QL minus QC by S. What is tan theta? Tan theta equal to, all right, QL minus QC by P. QC by P. Clear? That is the tan theta, QL minus QC by P. What is QL here? QL equal to I square into XL. What is QC? This is inductive reactive power. It is a capacitive reactive power. That is I square into XC. It is about phasor diagram in terms of voltages, impedance triangle, power triangle. Understand? Every observation is important. Based on these formulas and these observations, already questions are filled. Now, up to now, I explained series RLC circuit with assumption of VL greater than VC, XL greater than XC, QL greater than QC. For same series RLC circuit, I have to draw the phasor diagram. Case 2 I am taking. Case 2 that I am taking. Please try by your own, all of you. Parallelly, please try by your own, sir. I am taking case 2 if VC greater than VL. Always resultant is in high voltage side. Then, as it is, I am drawing. We know that in a series circuit, current is the reference. Take this is the reference. I. And this is VR. VL is always leading with respect to current. But you take it is a small vector. VC, you take the large vector. Why? Because VC greater than V. Then these two, phase difference between these two is 180 degrees. Then resultant is always high voltage side. Which is high voltage? VC side. That is VC minus VL. Then this is the result. See how the vector is changing. This one shows VL greater than VC, na VL minus VC. Then it is like this. But this is like this. Then this angle is theta. Clear? VC minus VL. Now this is the V slopes. Then angles, you know how to calculate angles. All of you know this one. Then what about V equal to the magnitude of V equal to square root? How to write? V equal to square root. That is VR square plus VC minus VL whole square. VC minus VL whole square. This is only how to remember. VR square plus VC minus VL whole square. Then what are the cos theta students? Cos theta equal to, what is the cos theta? Come on. What is the cos theta? VR by V. This is fixed. What is sin theta? VC minus VL by V. Here you see, there is no change in the power factor. Here also cos theta equal to VR by V. Sin theta equal to VL minus VC by V. But here VC minus VL by V. That is only difference. What is the tan theta? Tan theta equal to, what is the tan theta? VC minus VL by VR. But in this case, what is the tan theta? VL minus VC by VR. That is only difference. Clear? This is for case 2 phasor diagram. Then what is impedance triangle in case 2? Impedance triangle. Impedance triangle. In case 2, let us assume that VC greater than VL means then you have to take the XC greater than XL. XC greater than XL. Then as it is, you draw. In a series RLC circuit, I is constant, resistance in phase with current, and this is XL. Vector is leading, XC vector is lagging. XC vector is lagging. But you take this is the vector is large vector because XC greater than XL. Then this is XC minus XL. XC minus XL because XC greater than XL. Then resultant is this impedance. At this angle is theta. Clear? Then what is Z equal to? Square root R square plus XC minus XL whole square. XC minus XL whole square. You have any doubts, sir? Why this VL vector is taken this direction, VC vector is taken this direction? This is the reason I will explain these terms. VL leads I angle of 90 degrees. VC leads I angle. VC lags I angle of 90 degrees. According to that only I taken steps. Please follow that. You have to draw by your own, don't by heart. Z equal to square root R square plus XC minus XL whole square. Then you write from this any formula. What is cos theta? Cos theta. Cos theta is always R by Z. What is the sin theta? This is XC minus XL by Z. What is tan theta? This is important, 5-star formula. That is XC minus XL by R. But in this case, XL minus XC by R. But here XC minus XL by R. Then from this, what is theta in RLC circuit, series RLC circuit? Tan inverse XC minus XL by R. You know this XC equal to 1 by omega C. XL equal to omega L. Now last one is, can you try for power triangle? Try by your own. Is it okay? Any doubt? Come on, students. Try to draw the power triangle. This I am writing drawing power triangle. How to get the power triangle? Every vector in a impedance triangle multiply with I square. Let QC greater than Q. So this is I square R P. This is I square XC. This is I square XL. The resultant is QC minus QL. And this is resultant S. And this is P. These angles, you know. Again, no need to write. These angles are 90 degrees. This is also. This is about the power triangle. Then what is S equal to, friends? Square. This is S equal to I square into Z. Square root P square plus is a QC minus QL whole square. QC minus QL whole square. What is the cos theta? P by S. This is fixed. Active power by apparent. What is sin theta? QC minus QL by S. What are the tan theta, students? QC minus QL by P. Tan theta equal to QC minus QL. But here, QL minus QC by P. QL minus QC by P. This is QC minus QL. That is about observations from series RL circuit, RC circuit, and series RLC circuit. In series RLC circuit, again two conditions: XL greater than XC and XC greater than XL. XC greater than XL. How to write the formulas? Now, before starting parallel RLC, you have to see some practice questions. A series RL circuit shown in figure, the voltage across inductor is. Come on, students. Can anybody answer this? Come on, do it. Any response? Yes. Given is RL circuit, you know this V equal to square root VR square plus VL square. VL square. Okay. This is 20 volts peak to peak value. 20 volts peak to peak means this is the sine wave. It's a AC sinusoidal analysis. 20 volts peak to peak is this is 10 volts. Then what about this value, students? This is minus 10 volts. Then peak to peak is 20 volts. Then what is the RMS? 10 by root. RMS is 10 by root. Okay. Now, shall I write like this? V square equal to square on both sides. VR square plus VL square. What is V square? 10 by root 2 whole square. What is VR? That is 2 square plus VL square. This is 100 by 250. 50 equal to 4 plus VL square. From this, what is VL square equal to 50 minus 4? That is 46. Then what is VL? Root 46. What's the answer? This observation is important. Don't substitute directly 20 volts. Given is peak to peak value. If it is a peak to peak value, 10 is the amplitude. RMS is amplitude by root, not 20 by root, 10 by root. Because given is not peak value. It is a peak to peak value. Then root 46, friends, how much you get? 6.8 volts you get. This root 46 volts, that is a 6.8 volts. That is option C is the right answer. It's clear? It's okay. Next. Can you try this? This is 2. Problem number 2. For the circuit shown in figure, find the ammeter. V1 of t is 2 sin t, V2 of t 3 sin theta, V3 of t 5 sin phi. What is the ammeter reading? You have to calculate. Constants. Come on, do it. Here there is a DC source is given, AC source also given. You know that first I am calculating separately for 4 volts DC source. If AC source is V1 is given, if AC source V2 is given, if AC source V3 is given, you have to calculate the currents. Then by taking all the currents, here it is given is a AC meter. This ammeter is the find the ammeter reading. It is a AC ammeter. It is taken as a MI meter or MI meter. Any AC meter only it is given. Yes. Now first, how to solve this type of model? Very important. First, I am taking for 4 volts DC source. DC source. Students, we know that this is a steady state AC analysis. At a steady state, this property is already given. Capacitor acts as a which one? Open circuit. Acts as a open circuit. If capacitor acts as an open circuit, then what is the current in the circuit? This is open circuit. then current in the circuit equal to 0. Then for 4 volts DC source, I4 DC, for 4 volts DC source, the current equal to 0. There is no current in the circuit. Next, if V1 of t is applied, now I am calculating for V1 of t. For V1 of t equal to 2 sin t, 2 sin t. Then what is omega here, friends? Omega t, omega is 1 radian per second. X equal to 1 by omega c. 1 by omega is 1, c is 1 farad. This is 1 ohm. R is also 1 ohm. R is also 1 ohm. Then what is the impedance? What is the impedance? It is the RC circuit impedance is R minus jXC. That is 1 minus J1. Then corresponding to V1 source, I am calculating the I1. I am calculating RMS current. This is I1 RMS. Calculating RMS value, substitute 2 by root 2. Why it is a peak value? Na? I have to get RMS value by root 2. Square root 1 square plus 1 square. Root 2 into root 2, 2 by 2, 1 ampere. That is for AC source, for V1 source, I1 equal to 1 ampere. If V2 is applied, what is V2 of t equal to? For each source separate, I am calculating that. What is V2 of t equal to 3 sin 3t? 3 sin 3t. What is omega? 3 radian per second. 3 radian per second. Now, how to calculate what is XC? 1 by omega c. 1 by omega is 3, c is 1 farad. 1 by 3. What is Z equal to? R minus jXC. R is 1 ohm. Sorry, R is how much ohms? That's 1 ohm. J, XC is 1 by 3. X is 1 by 3. Then you have to write 1 minus J by 3. Then you find what is I2, corresponding to I2. But this I am calculating RMS current. Sir, why you are calculating RMS current? Take this is the AC meter. This meter is the AC meter. Because you are measuring the AC current, they use the AC meter. Okay. If it is a PMMC, no need to do all these calculations. Your answer is 0. Because average current is 0. DC current is 0. Now, if it is a PMMC, answer is 0 only. But it is a AC meter. Then what is I2 RMS? 3 by root 2, maximum value by root 2, square root, impedance. 1 square plus 1 by 3 whole square. That is 3 by root 2 into, simplify this, that is 9 plus 1, 10. Root 3, that is 3 by 10. 3 by 10. Then what is value you can get? Check it. This is root 10. Root 10. This is 9 by root 20. 9 by root 20. This is 8. Next, one more source is given. V3 of t equal 5 sin 5. If V3 of t equal to 5 sin 5. Then what is omega, students? 5 radian per second. What is X equal to? 1 by omega. C is 1 farad. That is 1 by 5 ohms. What is Z equal to? R minus Jx. 1 minus J by 5. Then what is Z equal to? Then what is I3 equal? This is I3 RMS. I am calculating RMS current. Yes. 5 by root 2 by square root 1 square plus 1 by 5 whole square. That is 5 by root 2 into 5 by, this is 25, 26, root 26. That is 25 by root 52. 25 by root 52. Now, what is the ammeter reading? What is the ammeter reading? The ammeter reading equal to, it is AC meter, it measures RMS current, total RMS current. I already given the formula, I DC square plus IM1 by root 2 whole square, IM2, if it is a current, IM2 by root 2 whole square, plus also. But instead of IM1 by root 2, I am taking RMS value directly. I DC square, IM by root 2 is the RMS value, I1 RMS square, I2 RMS square, plus I3 RMS. By root 2, if you take by root 2, you substitute maximum value. Directly, I am substituting RMS value. Then what is IRMS equal to? Square root. What is IDC? 0. What is I1, students? How much I1 you calculated? 1 amp. That is 1 square plus. What is I2 you calculated? 9 by root 20 square plus what is I3 you calculated? 25 by root 52 square. Can anybody answer how much you got? I'm expecting answer from you. Can anybody respond? 1 square plus 9 by root 20 whole square plus 25 by root 52 whole square. Come on, come on. What is the answer, friends? Nobody responding. I got 4.13 amperes. Is it correct? Is equal to 4.13 amperes. That is option C is the right answer. Okay, this I'm leaving for you homework for practice. Find the power factor of the circuit shown in figure. Apply the same method. Find the current. You find this current. How to solve? Just idea I'm giving. First one is for 4 volts DC source. DC source. At steady state, given is inductor, not a capacitor. At steady state, L acts as a which one? At steady state, inductor acts as a short circuit, no? Acts as a short circuit. Then inductor for DC, I'm talking about DC. Then what is IDC? If it is a short circuit, only resistance 4 by 1, 4 amps. Similarly, calculate for V1 of t. What is I1? V2 of t. What is I2? V3 of t. What is I3? Okay. Then you calculate RMS values. What is Z here? R plus JXL. What is XL? Omega S. Once calculate this, what is IRMS? You can. This IRMS. But here the question is asked, what is the power factor? What are the power factors? Then how to calculate the power factor? Once you know the currents, then how to calculate the power factor? One formula for power factor is P by S, no? I square R by VI. I square R by VI. This I cancel. IR by V. You already know this is I. Already R value. How to calculate V? All these are RMS values. V equal to square root. Different frequencies na 3 omega t 5. Sorry, 3 t 5 t like this na 4. 4 square plus 2 by root 2 whole square plus all these are series connected. All these are added. All these voltages. Then for this 4 square plus 2 by root 2 whole square plus 3 by root 2 whole square plus 5 by root 2 whole square. You can get RMS value. Substitute here. I value substitute, R value substitute, V value substitute. Then what is the power factor? That I'm leaving for. Now to prove that we can get approximately 0.71 lakh. That is what this option is. That remaining you do now. Can do now. That is what is V1 corresponding to V1. Frequency is 1 radian. Here 3 radian. It is a 5 radian. Directly R plus JXL. XL equal not 1 by omega. This XL equal to omega because of inductor. Because of inductor. Clear? Yes. Can you try this? For the circuit shown in figure, if the power dissipated in 5 ohm resistor is 10 watt, then power factor of the circuit is power dissipated in 10 ohm resistor is 5 5 ohm resistor is 10 watt. Then power factor of the circuit is apply the conditions. According to condition only how to solve. What condition it is given? Power dissipated by that is P equal to I square R. How much P is given? 10 watt. This is I square into what is the resistance? It is a 5 ohm resistance. From this, what is I equal to root 2 amperes? If I equal to root 2 amperes, we know that P equal to VI cos theta. VI cos theta. P equal to VI cos theta. Then this P equal to Vi cos theta. Then what is P equal to I square? That is Vi cos theta. That is what is I calculated? Root 2. How much resistance? The resistance is how much? Is a total resistance. Now you have to take the total resistance. Condition is power dissipated by 5 ohm resistor is 10 watt. It is asking that what is the power factor of the circuit. In the total circuit, what is the resistance? 50, not 5. What is the voltage? 50 by root 2, RMS value. What is I? Root 2. I is root 2. Into cos theta. Into cos theta. Then root 2 cancel. From this, what is cos theta equal to? 2 into 15 by 50. That is 30 by 50 squares. How much you can get? 0.6. Then cos theta, that is power factor equal to 0.6. It is a lagging or leading. The element is inductive. This is RL circuit. The power factor is lagging. That is 0.6 lagging is the right answer. You apply this condition. Directly don't calculate. The power dissipated by 5 ohm resistor is given 10 watt. Using this condition only, you find the power factor. Next. Can you try this? A RL series circuit has resistance of 20 ohms and inductance of 0.92 Henry. It's not 0.92 Henry, it is a 0. Please correct it, it's a 0.02 Henry. 0.02 Henry. Correcting this. It's a 0.02 Henry. Okay. If the net impedance of given circuit is 40 at angle of pi, the frequency of the circuit is. You have to find what is the frequency of the circuit. Can you try this? You know that Z equal to R plus JXL form. R plus JXL. Why taken instead of R plus JXL? Here given is inductance, no? Inductance, R plus JXL. We shall write like this: 20 plus J omega F. 20 plus J omega is 2 pi F. L is 0.0. That is 20 plus J. You simplify this one, friends. 3.14, 6.28, 6.28 into 2. This approximately how much you can get? 6.28 into 2. So that that is 0.1256. 0.1256. JF into 0.1256. This is Z squares. We know that R equal to more or less, but you have to find frequency term. Na? What is XL equal to? More or less of Z. XL equal to more or less of Z sin theta. XL equal to more or less of Z sin theta. What is sin theta equal? What is the cos theta equal to R by Z? Na? Cos theta equal to R by Z. How much resistance it is given? 20 ohms. How much effective impedance it is given? 40. This is 0.5. Then what is theta? Cos inverse 0.5. How many degrees? 60 degrees. Now what is XL? You tell. This is XL. Na? This is XL. This JXL form. Na? XL. Then F into 0.1256 is equal to more or less of Z. Z is 40. Sin theta is 60. From this you calculate F. 40 into sin 60 root 3 by 0.1256. Can anybody? What is the answer? There is one more method also you have to apply. You can also solve like this. What is Z equal to square root? R square plus XL square. Z equal to square root R square plus 2 pi FL whole square. Substitute all the values here. Find the frequency. This is one more method. Like this also you solve. Then 40 into root 3 by 2 by 0.1256. Can anybody respond? What is the answer? This I got 276 hertz. Is it correct? 276 hertz. The frequency equal to 276 hertz. That is option B is the right answer. Next. In the following circuit, the voltage across inductor and source voltage respectively. We have to calculate what is the voltage across inductor and source voltage. Yes. To find the voltage across the inductor, apply the formula for these two elements. Apply the formula for these two elements. If you apply formula for RL circuit, solving this. First, I am applying formula for RL circuit. For RL circuit, how we can apply? V equal to square root VR square plus VL square. Then V square equal to VR square plus, this I am applying VRL. VR square plus VL square. But what is the VRL? It is given 5 volts, 5 square. What is VR square? 3 square plus VL square. Then from this, what is VL square, students? Square root 25 minus 9. Sorry, not square root, VL square. That is 25 minus 9. This is equal to 16. Then what is VL equal to? Square root 16. That is 4 volts. VL is 4 volts. You have to find across inductor and source voltage. In the given option, VL is only one option. A is correct. But how to calculate V? How much VL you got? 4 volts. What the VC it is given? 8 volts. Then you apply VC greater than VL. Then if VC greater than VL, what is V equal to? Square root VR square plus VC minus VL whole square. What is VR? VR is 3 square. What is VC? 8. What is VL? 4. This, by simplifying this, how much you can get, students? 5 volts. Then you can get V equal to 5 volts. Like this you can solve. That is, VL is 4 volts, V is 5 volts. Find voltage across capacitor of the circuit shown in figure. Can you try this? Find the voltage across capacitor shown in figure. Students, here VL is given how much? 20 volts. VR is given 5 volts. V is given 13 volts. Okay. But you have to find VC. But we don't know VC greater than VL or VL greater than VC. That's why two values are possible. Simply without solving also, option C is the right answer. 8 or 32 volts. Then you can see, for example, if you assume that if VC greater than VL, then what is V equal to square root? You have to write VR square, V square equal to, how you can write is V square equal to VR square plus VC minus VL whole square. This is 13 square equal to, what is VR? 5 square. VC, you have to find VL, 20 whole square. This is 169 minus 25. VC minus 20 whole square. 169 minus 25, 144. Equal to VC minus 20 whole square. From this, what is VC minus 20? 12 volts. What is VC? 32 volts is right. But I'm assuming that VC greater than VL. Now I'm taking one more condition. I don't know because VC greater than VL or VL greater than VC, you don't know. That's why if VL greater than VC, then apply V square equal to VR square plus VL minus VC whole square. This is 13 square equal to 5 square plus, you have to find VC now. VL is how much? VL is 20. 20 minus VC whole square. From this, what is the 20 minus VC whole square equal to? 169 minus 25, na? 144. What is the 20 minus VC? 12. From this, what is VC? 20 minus 12. That is 20 minus 12 is 8. That's why it is not exactly 32. Any possibility. 32 is possible or 8 because we don't know about VC greater than. That is 8 or 32 volts is the right answer. 8 or 32 volts is the right answer. Clear. Now these questions I'm giving homework for practice. How to practice all these questions. And this also homework. How to practice. This also homework for practice. Practice this. Now with this, a sinusoidal AC source across series RLC circuit. Series circuit is complete. A sinusoidal circuit is complete. The next session will continue with the parallel circuit, and you have to see some problems with respect to parallel circuits. Then power calculation in single phase AC. With that, AC analysis will complete. Then we will start with the resonance and the coupled circuits. All these problems later. Students, thank you. I'm ending the session. Any doubts? Please collect all these PPT from my Telegram channel. Smart gate rankers. All are small letters. SMART, smart, GAT, gate, RANKER, smart gate rankers. Thank you. I'm ending the session.